Let us learn the motion of a projectile in a resistive medium. Here, resistive medium is a medium which opposes the motion of projectile. It means such medium provides a resistive force which opposes this projectile motion, and such force which is resistive in nature, that is always perpendicular, that is always proportional to velocity, and such force is also known as damping force, and we can write that such damping force is equal to minus B and V. Here B is damping factor, and negative sign shows the opposing force. So when a projectile is fired, when a fired, then two types of forces act on it. Types of forces. Oops. Forces act on the projectile are: number one, weight of projectile, which acts vertically downward, and second, damping force, damping, or you can say resistive force. So means these two types of forces act on the projectile. Under the action of these two forces, let us assume that a projectile is fired in YZ plane such that x-axis is along this side. So we assume that projectile will move only in y and z plane. Let us assume it is fired with initial velocity v naught, which this velocity can be resolved into two components. One is v cos theta, which is along y-axis, and v sin theta, which is along z-axis. And at time t, we have to find this motion of projectile, mean I have to find the displacement or the position of this projectile at time t. So that is our objective to find in the motion of a projectile in resistive force. So we will start with the second law of motion, in which we equate all type of forces on the net force on this projectile. So we write this weight as m into g, but because it is acting along z axis, because the weight of the object will be downward direction, m into g, therefore we will mark it like minus k, because k is upward and this is downward, therefore we mark this force, it is negative of k, so we will write it as minus k. And since damping force is resistive force, it is directly proportional to velocity, and therefore this force will be written as, we will write it as minus bv. So let us write down equation of motion. Equation of motion of projectile is, we write net force is equal to this minus k mg, that is weight, and minus bv, that is resistive force. But this net force may be written as m into d2r over dt square is equal to minus k mg bv. This mass can be taken to right hand side, and this d2r can be split, as we can write it implies further d by dt of dr by dt equal to minus k. When I bring this m to right hand side, this m cancels, we left with only g minus b over m into v. But we know that dr by dt is velocity, therefore I can write it as, it implies dv over dt is equal to minus k g minus b over m v vector, which can, here negative sign can be taken out, and we can write k g plus b over m into v vector. So let us bring now this dy dt. I will keep dy dt here, and I will bring this vector to left hand side because velocity is there and we have velocity variable here. So we can write this equation as, again we will write implies dv vector divided by k weight, that is the weight component, plus b over m v equal to, minus sign is already here, minus, and dt goes that side, we can write like this. Now integrating this part, we get, because it is dv over, it is just like a x, so we can write dv over v, mean it will be log x on integrating. So we write integrating both sides, we will get, what we will get here, we'll get log of this denominator, that is k g plus b over m into v vector, and since this is not alone, this coefficient is there, so we have to differentiate this in the denominator of it. So we will write differentiation of this vector dy dt dy dv of b by m into v vector equal to this dt, that is integration of dt, that is d minus plus some constant k. This equation is further solved. We will find differentiation of this, that will be bm only, so we will divide it by bm, and if I take bm in the numerator, so I can write here, it gives me m over b, this goes up, then log of this bracket k unit vector along z axis g plus b over m v is equal to minus t plus k, where k is constant of integration. Now we have to find this k by using initial conditions. Using initial conditions, what are those? That is, at time t is equal to 0, we had V is equal to V naught. That we know from the diagram that at V t is equal to 0, V was V naught and it has two components. So using this, we can write here in this equation, we will write that m over b log of k g plus b over m v naught is equal to t is 0 plus k. So from here the value of k is this. Let us put this value in this equation. So we get, putting equation of k in this equation, in above equation number, let us give number to this equation, let us give number as 1. So in equation 1 we will put, we get, this is number 1, equation 1. We will write m over b as it is, log kg plus b over m v, and equal to minus t is already there, plus k from value here, that is m over b log of k g plus b over m v naught. So this is the value we get. Here we have v, here we have v naught. Now you see this term is just like this term. Let us bring this term to left hand side. This plus term will become negative this side. So I will write it as, or m over b, since here we have m over b, here also we have m over b, let us keep it outside, common. Inside I will left with log k g plus b over m v, and this term becomes negative this side, log k g plus b by m, here we have v naught now, equal to, this bracket will be closed here, this one, equal to, we will get minus t. Okay, now since log a minus log b may be written as log a over b, I can write this equation as m over b is common here, I take log, then common log, if this term is in the numerator, so I will write k g plus b over m v vector divided by, this is negative term, it will come down, so kg, it is in the denominator, b over m v naught. So this term becomes like this, equal to minus t. Okay, let us take this m over b to right hand side, then this equation will give me, log term will remain as it is, log of k g plus b over m v over k g plus b by m v naught equal to, this term comes to this side, so we get b over m into t. Now if I want to remove this log, I have to take exponential both sides. Taking exponential both sides, or taking log to other side, it will become exponential. So therefore this equation will become, we have to mark all the time implies, this term will become k g plus b over m v vector divided by this term, that is k g plus b over m this term is into V naught, this vector comes here, equal to, this term is here, equal to exponential, now exponential of minus b over m into t. Okay, and let us take denominator to right hand side. It further gives me, numerator will remain here, that is k g plus b over m, v vector will remain here, and denominator comes to right hand side, that is k g plus b over m v naught, exponential term e minus b over m into t. So this is the equation. Now here we have sum of two terms. Let us take kg to right hand side, it become negative. So I left with now this term only, that is b over m v vector as it is. This kg goes to right hand side, it become negative there. K prime g, this term become negative, plus this bracket is already there, k prime g plus b over m v vector naught exponential of b over m into t. So this is the term. Now let us take this bm to right hand side, so it will become m over v here. So it gives me now v vector is equal to minus k, this goes m over b into g, plus here also I have to multiply b of m over b into k g plus b over m v naught exponential of minus b over m into t. So let us make it up. Then now this is the velocity of projectile at any time t. This is the this is velocity, because earlier we knew that that velocity, we know that initial velocity is there, but what is the velocity at this moment? So that velocity, if I want to know that what is the velocity at this moment here, v, and this velocity we get from this equation here, and it means here at this moment also this velocity may have different components, because in the starting it has all components x, y and z. Here also it may have all components. So let us find the components of these velocities. For that I will write this velocity in components. On the left hand side I will write this velocity as let us say I, oops, let me take the initial ink here. So I will use velocity vector, sorry, it is, so the velocity may be written as v is equal to I cap v x plus j cap v y plus k cap v z. So I have written all the components of velocity equal to minus k, that is z axis, m over b into g, this is first value, plus m over b, inside I have to write k into g, this value, plus b over m. Now here v naught has also two components, so I can write here first component, that is along j axis, so I will write j v naught cos of theta plus b over m, this b over m, k v naught sine of theta. Okay, I have written this value here. Multiply by this whole term, this bracket goes here, this theta here. This whole term goes here, and it is multiply by e minus b over m into t. So this term comes here. Now you see, I have to compare both sides. If I have some, we have x-axis, we should write x-axis from here. But you know, in whole equation here, we don't have any term along y-axis. Therefore, on comparison, we can write on comparing both sides, we get, what we get is that Vx is equal to 0. That means there is no component of velocity along x-axis, and that is clear because in the starting there was no component along x-axis. Let us find what is along y-axis. So we will write Vy is equal to, here this is along z-axis, this is along z-axis, but this is along j-axis, that is y-axis, and therefore let this is also along z-axis. We will write only this term, but this term is multiplied with m over b here and b over m here. Okay, and it is also multiplied by this term, so I will write here m over b into this m over b, then this b over m in bracket, here I will write, uh, let us write only v naught cos of theta, this cos of theta, then I will close this bracket here, multiply by this e minus b over m into t. Now you can see that bm or m will cancel out if I multiply it inside, then we get only, it will give me v naught cos of theta into e minus b over m into t. Here we can put bracket so that it will be separate. Let us write now the z component, that is vz, and vz for we have to write all key components. So first component is minus m over b into g, plus here we have m over b, let us write here, then k, not k, let me write only g here because k shows the z-axis, then we have this k component plus, I will write plus v naught sine of theta multiply by this b over m here, and let us close the bracket and multiply this factor e minus b over m into t. This is something which we get after solving for zx. Let us write this equation again. Here we get vz is equal to, mb is here, let us take this mb common, m over b, so I will write m over b common here, and inside I will left with minus g first of all, plus this m over b goes out, I left with inside bracket g, plus here I can write b over m, in bracket I will write v naught sine of theta, then I will close the bracket and I will multiply by minus b over m into t. So you see, these are the three components of velocity, vx, vy and vz, and these components will be shown over here. In this case, at this point this is the component of velocity v, and it will have three components here. One is along y-axis, one is along z-axis, and there is no component along x-axis. Therefore, that factor is here 0. So let us stop here with the components of velocity, and in the next video I will tell you how to find the position vectors or the position of the projectile at time t.